Hi everyone, this is Kaladevi. Today we are going to learn basics of IP addressing in computer networks. So what is an IP address? Why we need IP address? Suppose your computer want to computer somewhere else in the world want to communicate with another computer somewhere else in the world. They need internet. Through internet computer can communicate, but in the internet the computer need IP address. We need an address. So for an example, we can identify by using name and address. Similarly, the devices connected in the intra-network need IP address to communicate from one device to another device. An IP address or Internet Protocol address is also called as logical address, which is a series of numbers that identify any devices in a computer network uniquely. So computers uses IP address to communicate with one another through internet as well as through other networks in the internet. IP address is of 32-bit long, which is unique to identify a device. The device can be of anything. It can be a router or computer, or it can be a handheld device, laptop, it can be anything. So each and every device has its own IP address. The IP address, valid range of IP address is from 0.0.0.0 to 255.255.255.255. The worldwide any devices which are connected in the internet, it should be of unique IP address. So normally the IP address of 32-bit address, they provide address space up to 2 power 32. Theoretically, more than 4 billion devices can be connected to the internet if there is no restriction. So every computer in a network is called as a host. The host can be a laptop, desktop, or any handheld devices. It can be server, or it can be a wireless devices. Each devices which are connected in the network has its own IP address. For example, the laptop has an IP address in this figure 192.168.1.100. This is an example of IP address which is assigned to a device. So similarly, all other devices which are connected in the internet, it should need a IP address. So each device which are connected need pair of addresses such as logical and physical addresses for each connection. So each device has pair of address, logical and physical address. So each device in this given network, in the intranetwork, has MAC address and IP address. For an example, host A which has IP address and also has its own MAC address. MAC address which is provided by network interface called manufacturer. So it gives the physical address of the computer to identify the device in a network, in the local network. But IP address which is provided by internet service provider, which is called a logical address. So it is assigned by internet service provider to a computer which is connected in the network. So by using IP address, computer communicate with one device to another device. In general, Internet Protocol address can be classified into IP version 4 and IP version 6. IP version 4 is of 32-bit address and IP version 6 is of 128-bit address. So here in IP version 4 there is address space of more than 4.3 billion addresses. IP version 6 provides address space of 7.9 into 10 power 28 addresses. So in IP version 4 address can be reused. In IP version 6 every device can have a unique address. So in IP version 4 there are 4 octets in the IP address. In IP version 6 there are 8 segments in the IP version 6 address. So each in IP version 4 the IP address are separated by octets with 3 dots. So each here the X is called as an octet. So the X varies from the range from 0 to 255. In IP version 6, IP address can have a hexadecimal value between 0 to FFF. So the example of IP version 4, 192.168.5.1, and the IP version 6 has 8 octet in hexadecimal form. So IP address are divided into two parts, network part and host part. In network portion and host portion. So here the IP address are broken into 4 octets. Each octet has 8 bits. Then generally IP address can be represented in two notation, binary notation, and another one is dotted decimal notation. Binary, that is IP address, are divided into, can be represented as, the IP address can be represented as two notation. One is binary notation and another one is dotted decimal notation. In binary notation, the addresses are in the form of bits. The bit can be either 1 or 0. The minimum value in every byte can be of 00000 to maximum 111111. So here 000 is the lowest value and all bits of 1 is the highest value can be given as a IP address value in binary notation. In decimal notation, the same address can be given in the dotted decimal form. So the decimal value the value in each octet can vary from 0 to 255. For an example, 117.149.29.2. So this is the IP address which is represented in decimal notation. So here in this IP address there are 4 octets. So each octets are separated by dot. So here the binary form of IP address and the same IP address is represented in decimal form, as shown in the example. So IP addresses uniquely identified devices which are unique. It uses 32-bit address. Generally, IP address which use the concept of classes. This architecture is called classful addressing. Classful addressing. The address space is divided into 5 classes. In IP address, the classes of IP address are divided into 5 categories: class A, class B, class C, class D and class C. So in class A, in binary notation, class A IP address start with 0, class B IP address start with 10 and class C IP address starts with 110, class D starts with 1110 and class E starts with 1111. If any address starts with 0, that comes under class A IP address. If any address starts with 10, that comes under class B IP address. So by looking the first few bits in binary IP address, we can identify the classes of IP which belongs. In dotted decimal notation, class A IP address starts with 0 to 0 and ends with 127. In class B, the first byte it starts with 128 and ends with 191. In class C, the IP address starts with 192, class D starts with 224 and class C starts with 240. So by using this first byte of IP in dotted decimal notation, we can identify which bit class the IP address belongs. So IP address consists of network address and host address. Network ID, which is used to identify the network. We can identify the network by using network ID. In host ID, we can identify the host to which the networks it belongs. So network ID which is used to identify the network, host ID which is used to identify the host in the network. So here So the few ranges are allotted for network ID and host portion in the classes of IP address. So in class A, first byte is allotted to first octet is represented as a network ID and remaining 3 octet to represent host portion. In class B, first 2 octet represent network part and next 2 octet represent host portion. In class A IP address, first 3 octet represent network portion and last one octet represent host portion. Class B address start with 224. If the IP address starts with 224, that address is called multicast address. Class D is reserved for multicast address. Class B allotted for multicast address and class E address is reserved for future purpose, can be experimental purpose or research purpose. This is reserved. And private, there are IP address generally can be classified as private IP and public IP. Private IP which can be used within the same network. Suppose if any organization want to build their own network, they can use private IP. So any devices uses a private IP, the host can communicate within a network. If any host in a network want to communicate with the internet as computer in the internet, they have to use a public IP address which is provided by internet service provider. So host in a local network can communicate with internet network by using public IP address. The private IP address, there are in different classes, the various range of IP is reserved as a private IP. If IP starts with 10.0.0.0 and in class A, it ends with 10.255.255.255. This address can be used as a private IP. In a college network, RIP also starts in class A, 10.1.5.8. So this is private IP address. Public IP, there are some special address which is used for special purposes. The special address 0.0.0.0 which is used to communicate with the local network and 127.0.0.0 is used as a loopback address and 169.254.0.0.0 which is used as a link local address. So IP address are assigned in a network should be unique. So we can, if it is a private network, we can use a private address. If it is a public, if any system, actually we have to allocate IP address for each and every devices in a network. The devices can be of computer or the devices can be an intermediary device or can be an end device. Both the end device and intermediary device like your router, it should have an IP address to communicate with one another. So in class A, in classroom addressing, class A use 8 bits as a network bits, 24 bits as a host bits. So in network, in class A, totally there can be 128 networks. So totally we can create 128 network in class A IP address and we can connect 2/24 hosts in a class A address, in a class A network. In class B, 16 bits as a network bits and 16 bits used as a host bits. So totally we can have 2/16 networks in class B and 2/16 number of hosts in class B network. In class C, 24 bits as a network address and 8 bit as a host address. So in class B, we can have a maximum of 2/21 networks and in each network can have maximum 2/56 hosts. And class D used for special purposes and class D used for multicast address and class D used as it's used reserved for future use. So it's a simple class C network analysis. So in the given class C address, actually class C address starts with 110. If any IP address starts with 110, it comes under class C IP. So in class C, first 3 octets represent network portion and last 1 octet represent host portion. So here totally there are in the network portion 21 bits are available for network ID. So totally there will be 12 power 21 networks we can create in this class A IP address. So in host portion there are 8 bits. So in each and every network we can have maximum of 2 power 8, that is 256 hosts. Thank you.